In classwork 3, we will take our quadratics and we will put them in a standard form. This gives us a vertex form, where h and k correspond to your x and y of your vertex. This form follows the way you do transformations. It follows a vertical and a horizontal shift as well as a vertical stretch. Horizontally, you're always going to move the opposite direction. So h is going to come out the opposite way, and k will stay the same. So we're going to start off with an easy one of x squared minus 4x plus 7. Now, if you asked me to graph this, I really wouldn't know where to put this. I can find its axis of symmetry if I had to by using your old formula, x equals negative b over 2a, turning it back in, finding the y. And the roots, I would have to use your quadratic. But to make this a long story short, we're going to complete the square to put this into vertex form. And completing the square says group these two x's. So we're going to group these x's. Now when you group your x's, regroup it and leave a space to fill in third term so that we can complete the square. Now bring down the rest of the equation, and because you added something into this equation, you have to subtract the same thing. Look at your middle term, your b, and take half of b. So half of negative 4 is negative 2. We square it. Then go 2 squared and put it right here, 4. When you put the 4 there, you will also have to subtract it so that you keep the same equation. To rewrite this, here's our standard equation, and just combine those like terms, plus 3. Now when you line this up to your y equals ax minus h squared plus k, you can see that your a is 1, and if it's greater than 1, greater than 0, it opens up. There's no stretch to this. If it's less than 0, it opens down. H, negative h is equal to negative 2, therefore h is equal to 2, and that goes by your horizontal translation, which would go 2 to the right, to the positive, and k is 3. So your vertex is 2, 3. From here, you could find your y-intercept. Go back to your original equation, and when x is 0, it wipes out these terms, so y is equal to 7. So here's your y-intercept. To find your x-intercept, set y equal to 0. Now instead of going back to your original equation, where we would have to do the quadratic formula, we go to your vertex form, use this guy, and substitute y out for 0, and solve. Subtract 3, and when you undo your square by taking a square root, you can see that you have an imaginary number. Therefore, you have no real roots to this equation. If we graph this, we would graph your vertex, 2, 3. We would be able to graph the point 0,7 up here, and we would get your parabola, and we would know what that looks like. And you can see you have no real roots. So we graphed this function, x squared minus 4x plus 7, and we knew where the y-intercept was, that it had no x-intercepts. We found the vertex, and the axis of symmetry goes right through this vertex point. It's a vertical line where x is equal to h, so your axis of symmetry is x is equal to 2. Now this next function, a is not equal to 2, is not equal to 1, it is 2. So you have to get this so that a is 1 in order for you to complete the square. So the first thing we're going to do is group these. And we leave a little space for the third term. We have our plus 7, and because we added in here, we have to subtract in here. In order for us to get a to be 1, out of the two x's, we have to factor out a 2. So factor out the 2, leave your space, and complete the rest of your equation. Back to half of b, take half of b, which is plus 2, so give it the x plus 2 squared. Bring down this 2 with it, it's a factor. Now you're going to square 2 and put it right here. Before we can take that out and put it in the other place, we need to redistribute this out. This guy has to be distributed from by 2 to 4 in order for it to get out of that parentheses. It would have to come back to your original 1. So if we distributed 2x squared plus 8x plus 8 over here, we would take the 8 and put it on this side. And again, this is still equal to y. So you now have your vertex form of your equation. And combine these terms to minus 1. Your vertex is still at hk. Now remember, your horizontal transformation goes the opposite way. So your 2 left, your negative 2, and your vertical is still a negative 1. So we have a parabola with a vertex of negative 2, negative 1, and we know that it opens up because a is positive. A is greater than 0, so a is positive. It opens up. From there, we can find your y-intercept. Go back to your original equation. Take out these with zeros, and y is equal to 7. So your y-intercept is 0, 7, up here somewhere. Now we need to see where it crosses the x-axis. We need to find the zeros, or the roots of this equation. So we come back to your vertex form, and we substitute 0 in for y, and we solve. We add 1, and divide by 2. Undo your square, and you get a square root, which gives you a plus or minus. To get x by itself, subtract 2. So your roots, or your zeros of your equation, are negative 2 plus radical 1/2 and negative 2 minus radical 1/2. These are your exact zeros. If you put them in your calc, you'll see that they're a little bit to the negative side there and a little bit there, so we know what our parabola looks like. And this 2 out in front of this shows you your vertical stretch. So from this original function, we can graph its vertex, all the zeros, the intercepts. We can look at the axis of symmetry. It's the vertical line that passes through the point. Your vertex was 2, 3. This is your x, your y, your hk. So your axis of symmetry is x equals h. X is equal to 2. Oops, sorry, in this case, negative 2. Negative 2. Okay. We can also work this in reverse. We can find his vertex at 1, 2, and passes through the origin, the 0, 0 point. So here's your 1, 2, and it's passing through the origin. In order to pass through this origin over here, this has to come down like this. So we've got a parabola whose a must be negative. So we start with your basic format. We substitute in the h and the k. So we get y is equal to a, x minus the 1 squared, plus 2. Now, from here, we're going to substitute in your x and your y point because we need to solve for a. We have 3 variables, so if we use your origin as an xy, we can substitute that out and leave us with 1 variable. And then resolve your equation. Negative 1 squared is 1, so we have 1a plus 2. Subtract 2, so a is equal to negative 2. Then put it all back together. Negative 2, x minus 1 squared plus 2. Now, that's it in vertex form for your parabola. And the negative 2 shows that it opens down, and the 1, 2 shows your vertex point.